In the mid-20th century, mechanical wristwatches were the standard for personal timekeeping, but they had inherent limitations in accuracy and required frequent winding. By the early 1950s, watchmakers were seeking ways to leverage new electrical technologies in order to improve precision.
These tiny transistors are destined to play a big part in our electronic age. They will make possible smaller, more compact electronic devices that will need less maintenance and have a longer life.
The first attempts at electric watches simply replaced the mainspring with a battery power source driving a conventional balance wheel. Like the Elgin Watch Company, which produced an electrical watch in 1952, and Hamilton introduced the Electric 500 in 1957. These pioneering models used batteries, but still relied on traditional balance oscillators, so they offered no significant precision boost over purely mechanical watches. Bulova, a storied American watch firm founded in 1875, found an opportunity to push beyond these early electrified designs. In 1950, the company recruited Swiss engineer Max Hetzel to lead a top-secret project to develop a radically new electronic watch, with unprecedented accuracy. This bold initiative, which Bulova codenamed Accutron, aimed to fundamentally improve on two weak spots of mechanical watches at this time: limited power autonomy and inconsistent precision. Under Max Hetzel's direction in Switzerland, Bulova's research focused on using the newly invented transistor and an innovative timekeeping element, a tiny tuning fork.
This is a balance wheel. You will find one in every watch in the world. This is a tuning fork. It runs on an electronic circuit and keeps time by vibrations.
Hetzel's idea was to replace the low-frequency balance wheel, which typically oscillated at 2.5 to 5 Hz in a mechanical watch, with a high-frequency metal tuning fork oscillating hundreds of times per second. By using electromagnetic coils and a transistor circuit to drive the fork, Bulova hoped to achieve far greater stability and accuracy than mechanical movements. The concept was ambitious. Tuning forks had previously been used in clocks and musical instruments, but never in a wristwatch. But progress came quickly. Bulova filed a patent for a transistorized tuning fork watch on June 19, 1953, and the first working prototype was completed by 1954. Over the next few years, Hetzel built multiple prototypes, steadily refining the design, and by 1959, Bulova engineer William O. Bennett had developed Caliber 214, the first fully functional tuning fork watch movement ready for production. This new movement was unlike anything before it. The fork-shaped resonator inside the watch vibrated at 360 Hz, far faster than any balance wheel, dividing each second into 360 oscillations. And this high frequency translated to remarkable accuracy. Bulova could guarantee the watch would run about plus or minus 2 seconds per day, or about a minute a month, a level of precision unheard of in watches of that era. In fact, Accutron was coined as a contraction of accuracy through electronics, getting at the project's core goal. After nearly a decade of secret development, Bulova was poised to introduce a technological breakthrough that would revolutionize timekeeping. Bulova's Accutron was the world's first fully electric wristwatch, and its inner workings were a marvel of mid-century innovation. Instead of a mainspring and balance wheel, the Accutron's time base is a tuning fork-shaped metal blade about 25 millimeters long and driven by electromagnets. A tiny transistorized oscillator circuit, one of the earliest uses of a transistor in a consumer watch, keeps the fork vibrating at a precise frequency of 360 Hz. Each vibration of the fork's tines is converted through a pawl and index mechanism into a stepwise advancement of the watch's gear train, smoothly moving the hands. Though I should make it clear, it just appears smooth to the naked eye. We can't pick up on those 360 beats per second. The culmination of this holy grail, this search for a smooth, sweeping second hand, would only be eventually realized by the spring drive produced by Grand Seiko, coming about around 40 years after this. But this ridiculously high-frequency beat emits its distinctive, gentle hum at 360 Hz. An interesting quirk of the watch that people either love or hate, it's an audible reminder of that tuning fork resonator at work. Powering this system is a 1.35 volt battery, and so it removed one of the other pet peeves of that era, that a lot of the watches, especially the higher beat ones, would need a lot of winding. The use of an electric oscillator meant the Accutron was largely impervious to position or gravity effects that could disturb a balance wheel, and it also allowed Bulova to advertise an impressive 99.9977% accuracy. That's how it equates to a division of only a couple seconds per day. Compared to mechanical watches that might drift 15 to 30 seconds per day, this was truly transformative. The Accutron's design also got rid of the traditional side crown for setting the time. In the original models, setting was done by a small knob on the caseback, which Bulova touted as proof that the watch rarely needed adjustment. All these elements, the tuning fork, the transistor electronics, the humming sound, and the back set mechanism, made the Accutron an engineering wonder that was truly unique. It was the first watch to fully harness electric technology for timekeeping, paving the way for the quartz revolution that would follow in the next decade. Bulova officially unveiled the Accutron on October 25, 1960, marking a historic moment in horology. The watch was introduced to the public by Bulova's president and former U.S. General, Omar N. Bradley, in a high-profile press conference on October 10, 1960. This launch was accompanied by bold claims and fanfare. Bulova proclaimed the Accutron to be, quote, the most accurate watch ever, and the first major advancement in timekeeping in over 300 years. Early advertisements posed the evocative question, what is Accutron? To educate their customers about this mysterious new electric watch that didn't seem to tick. The Accutron went on sale to consumers in 1961, initially in select models in jewelry stores, and was an immediate sensation. One brilliant marketing move by Bulova involved a model that would come to be known as the Spaceview. The very first Accutrons delivered to jewelry retailers were demonstration pieces with transparent dials, designed to showcase this futuristic, sci-fi looking, unusual tuning fork movement. These exhibition watches had no conventional dial. Instead, the green-coated circuit board, gold-toned coils, and tiny mechanical parts of the caliber 214 were fully visible beneath the crystal. To Bulova's surprise, customers were entranced by this futuristic, skeletonized look and wanted to purchase the display models. Responding to demand, Bulova began producing official Spaceview models with clear dials for retail, starting in 1961. The Spaceview, so named to capitalize on the prevailing space-age enthusiasm, became an iconic showpiece of Accutron technology and design. Advertising campaigns highlighted the watch's unprecedented accuracy and its space-age aesthetic, helping drive early sales. And by 1963, Bulova had sold over 100,000 Accutrons. By 1965, over 350,000 units had been sold worldwide. Extraordinary numbers for what was considered a high-end watch. The Accutron was off to a running start, earning widespread acclaim for its ingenuity. But we should note that it's standing between the traditional mechanical watches and quartz watches that would emerge later in the 60s. And we should understand the differences from both. First is the timekeeping oscillator. A conventional mechanical watch uses a balance wheel and hairspring, essentially a mechanical oscillator, that beats at a few hertz, a few times per second. The Accutron replaced this with an electrically driven tuning fork oscillating at that 360 hertz. In contrast to a quartz watch, which was first introduced in 1969, uses a tiny quartz crystal vibrating at an even higher frequency, typically 32,768 hertz. And that is its oscillator. So Accutron was a midway solution, about 100 times more hertz than your normal mechanical watch, but the quartz would be at 100 times the tuning fork. The accuracy is also notable, that plus or minus 1 minute per month, about plus or minus 2 seconds a day, was better than the chronometer grade mechanical watches, which might drift from 2 to 5 seconds per day. But even early quartz watches in 1969 to 70 were even more accurate than Accutrons, at an order of plus or minus 0.1 seconds per day. But these initial models were extremely expensive and rare. So throughout the 60s, the Accutron was the most precise wristwatch movement available to customers. Now the new power source was something to get used to, and of course both the Accutron and quartz are using batteries, and so consumers had to decide if it was more convenient to replace a battery every 1 to 2 years when that battery died, instead of winding it a bit every day. Though quartz movements drew on so little power that the cells could often last for 2 to 5 years. Mechanical watches, especially of this era, were sensitive to position, temperature, and shocks, and would require maintenance after a few years just to get everything sitting perfectly again. The Accutron's electronic regulator largely eliminated potential errors and reduced maintenance needs, since there was no mainspring or escapement to wear down in the traditional sense. Though still, they did require specialist servicing. The tuning fork and index mechanism were delicate, and a misstep by an untrained watchmaker could easily damage the tiny index wheels or coils. Quartz watches, when they arrived, had even fewer moving parts and basically required no maintenance, just that battery change, and so this did hasten the obsolescence of the more intricate tuning fork mechanism. Now, its biggest draw and the hallmark of the Accutron was its smooth, continuous sweep, and even that unique, faint humming sound. The quartz watches would tick every second, and this is what most people who aren't really into watches think. They think of quartz as cheap, and you'll hear all the time from people, or in rap songs or just pop culture, that the Rolex doesn't tick, because it's moving smoother, no obvious jump from second to second. You're having several ticks per second, which make it appear smoother. And again, this seemingly fluid sweep of the Accutron is still several ticks per second, just 360 of them. But it's achieving something that's moving so smooth that it would only be topped in the 2000s by the spring drive. When it was released, there was a ton of genuine hype around this. In 1962, just 2 years after launch, the Accutron achieved a major vote of confidence in becoming the first wristwatch officially certified for use by railroad personnel in the United States. American railroads had extremely stringent standards for timekeeping, both in sticking to schedule but also in preventing collisions. This could actually save lives, and for decades they had relied on high-grade mechanical pocket watches. The Accutron's proven accuracy changed that, and by 1962, the Accutron's unprecedented accuracy made it so that eventually 75 different railroad companies all across the world adopted Accutron technology for their employees. This was a remarkable validation of Bulova's innovation and was used in a safety-critical setting. It also found favor in political and diplomatic circles. U.S. President Lyndon B. Johnson was so impressed with the watch that in 1964, he ordered 250 Accutrons to be given as official presidential gifts to visiting dignitaries. It was a prestigious symbol of American innovation. Giving one as a gift from the White House underscored the national pride in this achievement, and Bulova also capitalized on celebrity appeal. Elvis Presley was known to wear one, especially the Spaceview model around 1960, associating the watch with trendsetters. Meanwhile, Bulova's advertising saturated magazines, and even the new medium of television with the memorable slogan, "Accutron, it's not a timepiece, it's a conversation piece." Consumers were drawn to the idea of owning the latest space-age marvel on their wrist. That is not to say it was without its critics or challenges. Some traditionalist watchmakers in Switzerland were initially skeptical of electric watches, viewing the Accutron as more an electronic gadget than a finely crafted timepiece. Which, of course they're gonna say that. Just wait until I do the whole breakdown on Seiko. This skepticism would soon turn to alarm as Accutron sales surged, helping spur the Swiss to accelerate their own electric watch research. The Accutron was also a relatively expensive product in the 1960s, priced at the higher end of the watch market. Its novel technology meant that servicing required new skills and equipment, which not all jewelers possessed. If an Accutron malfunctioned, if one of its coils burned out or the tiny index wheel's teeth were damaged, it had to be serviced by a Bulova-trained technician or sent back to the factory. A point of criticism compared to the ubiquity of watchmakers for mechanical watches. And the dependence on batteries was a new inconvenience. Early Accutrons used mercury cell batteries, and if a cell died unexpectedly, the watch would stop cold, whereas the mechanical watch would merely run slow when it was due for winding. And of course, you could just wind it up wherever you are in no time at all. But nonetheless, these issues did little to dampen enthusiasm in the 1960s. Bulova sold over $30 million worth of Accutrons by 1964, and the line's revenue helped Bulova briefly claim the title of the largest watch manufacturer in the world, which I believe is currently held by Rolex. The Accutron was lauded in the press as one of the great innovations of the era, and it firmly entrenched Bulova as the leader in horological innovation. Now, the 1960s were defined by the space race, and Bulova smartly positioned the Accutron as the watch of the new space age. And Accutron technology really did go to space. Even before the wristwatch's official debut, Bulova had been working with NASA and the US military on utilizing Accutron timing mechanisms in aerospace applications. As early as 1958, prototype Accutron movements were supplied to the US Vanguard satellite program, making them some of the first electronic timekeepers in orbit. Throughout the 1960s, NASA integrated Accutron tuning fork timers into numerous missions. In total, Accutron technology flew on 46 NASA space missions during the 1960s. Not used as astronaut wristwatches, but as extremely accurate onboard timekeeping devices, like in spacecraft instrument panels, on satellites, and in other equipment where a stable clock was critical. Accutron's reliability under extreme conditions was tested and proven, and the tuning fork movement had some natural advantages for space. It wasn't affected by zero gravity like a pendulum or balance wheel might be, and its high frequency made it resistant to shock and vibration. In 1963, astronaut Gordon Cooper provided a dramatic example of the Accutron's utility. On the final Mercury mission, Faith 7, an electrical failure disabled the capsule's timing systems. Cooper used his Accutron astronaut wristwatch to time critical engine burns for re-entry, ultimately guiding himself back to Earth safely. The Accutron had literally helped to save an astronaut's life. The Accutron astronaut model he wore was a special 24-hour GMT version of the watch, which I'll talk about more in a sec, showing that Bulova had designed some Accutron variants with space and aviation in mind. Bulova's Accutron was also the first watch worn in space by an American. While the Omega Speedmaster is famous as the official NASA-issued moonwatch, several astronauts in the mid-1960s privately wore Accutron astronaut models during NASA training and flights, though not on the lunar surface. The X-15 rocket plane pilots, Air Force and NASA test pilots who flew at the edge of space were issued Accutron astronaut watches in 1961 and 62. The CIA's A-12 spy plane program, a precursor to the SR-71 Blackbird, also chose the Accutron astronaut for its pilots because the tuning fork watch could withstand the high G-forces and extreme temperatures in a way many mechanical watches could not. Of all the space connections, the crowning moment was the Apollo 11 mission of 1969. When Neil Armstrong and Buzz Aldrin took mankind's first step on the moon, they left behind an Accutron device on the lunar surface. The Apollo 11 lunar module's instrument panel contained Accutron timing mechanisms, and a battery-powered Accutron timer was installed in a seismograph experiment package on the moon. As a result, an Accutron timing unit remains on the moon's Sea of Tranquility to this day, silently marking time long after those astronauts departed. So although Omega's mechanical Speedmaster got the glory on the astronauts' wrists, Bulova proudly marketed the Accutron as the watch that went to the moon, even if you didn't see it on a wrist. In later years, Bulova would even produce commemorative models highlighting the Accutron's role in space exploration. The Accutron's space legacy solidified its reputation not just as a commercial product, but as a true technological contribution to scientific progress, at the very height of the space race. After the initial success of the basic Accutron 214 movement and the Spaceview, Bulova rapidly expanded the Accutron line throughout the 60s, introducing new models and improvements to broaden its appeal. The first major addition was the Astronaut in 1962, aesthetically similar to other Accutrons but added that GMT complication. It's the only variant to use caliber 214HN, with a specialized tuning fork adjusted for the GMT function. In 1963, traditional Accutron models with regular dials, available in various styles of gold and steel cases, were released to customers who preferred a conventional watch face over the avant-garde Spaceview look. While the Spaceview remained a conversation piece, these detailed models helped increase Accutron's adoption by more conservative dress watch wearers. By the mid-1960s, Bulova was also addressing other segments. Ladies' Accutron watches were introduced, featuring smaller movements to fit petite cases. The first was test marketed in 1965 and launched in 66, and used miniaturized tuning fork calibers like the Cal 230 and 231, operating at an even higher frequency of up to 480 Hz, helping to maintain accuracy in a smaller form. A huge improvement to their series came with caliber 218 in the late 60s, with production ramping up by 67 and 68. It was a thinner movement, 4.4mm thick versus the 5.5mm of the 214, and it does move the setting crown to the side of the case at 4 o'clock, a response to consumer feedback that a back-set watch was inconvenient. The 218 series enabled a range of new functions, date windows, day-date displays, and even a variant with a second time zone hand, the new Astronaut Mark II, which had a novel feature that let travelers adjust local time without stopping the watch. They also explored sportier designs, introducing the deep sea models, tuning fork watches with cases rated for scuba diving depths, some up to 666 feet, and these were among the first electronic diver's watches on the market. And in this time, we're seeing a continued refining of the case styles to suit late 60s tastes, including the famous cushion-shaped cases, lug-integrated designs, and a whole bunch more. By the end of the decade, the Accutron line was extensive, from the sci-fi Spaceview to the more tame and storied Astronaut to dressy gold models and rugged tool watches. But although they shook up the market with their new electronic pieces, an even more disruptive technology was on the horizon: the quartz wristwatch.
This tiny quartz crystal makes quartz watches the most accurate in the world today. It's the heart of Seiko's traditional analog quartz and continuous readout multi-mode LC digital quartz. Seiko pioneered quartz watches and today continues to expand the boundaries of timekeeping with the largest quartz collection in the world, all made with meticulous accuracy and matchless beauty.
In December 1969, Seiko introduced the Accutron, the world's first production quartz model. And in 1970, the Swiss consortium CEH debuted their Beta 21 quartz movement. Quartz watches used a high-frequency quartz crystal oscillator in electronics to achieve accuracy on an order of magnitude better than tuning fork watches, and their manufacturing costs plummeted as integrated circuits improved. It's cheaper, almost no maintenance, and nothing comes close to its accuracy. This development spelled trouble for the Accutron. Bulova's leadership initially hoped the Accutron could coexist or even compete with the quartz. It was a proven design with almost a decade-long head start in the market, whereas the quartz watch were very expensive and unproven curiosities. But the so-called quartz revolution, or quartz crisis, depending on who you ask, it advanced quickly in the 1970s, making tuning fork technology look increasingly outdated. Bulova took steps to respond. In 1970, they unveiled the AccuQuartz, a hybrid movement that added a quartz crystal to regulate the tuning fork, marrying the new quartz time base to the existing Accutron gear train. The idea was to maintain the beloved smooth sweep of the Accutron's second hand, but use the quartz for even higher accuracy. You can see a similar logic to what would become the spring drive. The AccuQuartz was technically the first quartz wristwatch sold in North America, beating other brands to the US market. But it was a transitional solution. Fully electronic quartz movements with stepping motors would soon dominate due to lower cost and lower complexity. By 1972 to 73, inexpensive, mass-produced quartz watches from Asia and new Swiss models flooded the global market, causing a steep sales decline for Accutrons. Bulova tried to compete by releasing the cheaper Cal 219 with some plastic parts and one transistor, but it wasn't enough. Issues with the tuning fork technology's cost, power consumption, and manufacturing complexity became liabilities in the face of this quartz competition. A tiny quartz crystal could vibrate at thousands of hertz with negligible battery drain, whereas Accutron's relatively power-hungry coils meant batteries typically lasted about a year, and the quartz watches were easier to assemble and didn't require the fine mechanical calibration that Accutrons did. Bulova made the difficult decision in 1976 to start fitting quartz movements into Accutron-branded watches, effectively ending the reign of the tuning fork. The very next year, 1977, Bulova ceased production of tuning fork Accutrons entirely. After an estimated 5 million Accutron watches had been sold worldwide over the previous 17 years. 1977 thus marked the end of an era. It was the end of Bulova's golden age of technological leadership. The Bulova Watch Company struggled financially in the quartz age and was acquired by the Lowe's Corporation in 1979, further signaling that the Accutron's movement had passed. In hindsight, the Accutron was a casualty of the quartz revolution that it had helped usher in. It opened people up to the idea of putting batteries in a watch. It was a proof of concept for electronic watches. They weren't some gimmick or inaccurate or prone to break down. But once quartz technology became affordable and widespread, tuning fork watches were rendered obsolete virtually overnight. But in the eyes of watch enthusiasts and historians, it earned its very respectable legacy. And by 1980, Bulova was actively replacing any returned Accutron movements with quartz modules if customers sent them in for service. The tuning fork was officially done. But wisely, they kept the Accutron name alive as a premium product line. In the 1980s and 90s, Accutron came to mean Bulova's higher-end quartz watches, capitalizing on their image of the accuracy and high quality. Enthusiasts, meanwhile, began to treasure the vintage Accutron watches. By the turn of the 21st century, early Accutrons, especially Spaceviews and Astronauts, had become sought-after collectibles, but finding them in working condition was increasingly difficult. Spare parts like index wheels and coils were scarce, and there were even less skilled repairers. Despite this, a niche community of watchmakers specialized in restoring Accutrons, and their distinctive hum could still be heard at watch fairs and collector meets. Bulova itself tapped into this nostalgia with a series of limited reissues and tributes. In 2007, they released a limited edition Accutron Astronaut, only 1,000 pieces, that faithfully recreated the 1960s design. Though sadly, instead of a tuning fork movement, it had an automatic mechanical movement. Famously, it was engraved with astronaut Buzz Aldrin's signature, and he became a Bulova brand ambassador, making sure to credit Accutron tech for its role in the space program. Then in 2010, to mark Accutron's 50th anniversary, Bulova stunned collectors by announcing a special Spaceview 50th Anniversary Special Edition that actually resurrected the tuning fork tech. This limited run, thought to be around 1,000 pieces as well, would see them engineering a new tuning fork caliber resembling the original 214, encased it in a vintage-style Spaceview design that was almost indistinguishable from the original 1960 model. Priced around $5,000 each, these anniversary Spaceviews were sold out before they even went into full production, a testament to the enduring fascination with the Accutron legend. In 2014, Bulova, by then owned by Citizen of Japan, one of the great winners from the quartz revolution, now they released the Accutron II series. These are homage pieces taking styling cues from classic Accutrons, including open dial designs like the Spaceview and alpha case shape, but instead of tuning forks, they use Bulova's high-precision, so-called precisionist quartz movements, calibers that vibrate a quartz crystal at 262 kHz, which gives them an accuracy of plus or minus 10 seconds per year, and also drives what to our eyes would look like a smooth, sweeping second hand.
Our latest breakthrough is UHF, or ultra-high frequency. It's quiet to the ear, yet a powerful breakthrough that marks the next level of watchmaking. This exclusive technology vibrates 8 times faster than the traditional 32 kHz crystal. The 3-prong vibrates at an amazing 262 kHz.
And so the Accutron II models deliver the visual effect of the original with improved accuracy, and these were priced in the few $100 range. They offered a retro-modern fusion and introduced a new generation to Accutron's aesthetic. Bulova even hid the crown on some models to mimic the clean look of the crownless Spaceview. In 2020, exactly 6 decades after the Accutron's debut, Bulova took an unprecedented step and spun off Accutron as its own brand, separate from Bulova, and launched an all-new Accutron watch with a groundbreaking movement. Rather than rehousing the tuning fork or a standard quartz, the new engineers developed a cutting-edge electrostatic energy movement that once again set Accutron apart from any other watch in the market. The flagship model of this revival is the Accutron Spaceview 2020. And again, there's just another similarity here with Grand Seiko, even that breaking off from its main brand to become its own separate thing, and they're just about alone in making such new cutting-edge designs, actual new movements. It's deliberately evoking the 1960s ancestor, having a skeletal dial exposing the movement with the signature green accents and copper coils. Under the crystal, it even carries a printed Accutron logo and minute markers reminiscent of the old Spaceview's crystal-mounted indices. But the technology underneath is thoroughly 21st century. The movement is a caliber NS30, uses electrostatic induction to generate power. As the wearer moves their wrist, twin micro-turbine wheels on the dial spin rapidly between electrodes, creating an electrostatic charge. This energy is stored in an accumulator, a capacitor, and is used to drive 2 motors. One motor is an electrostatic motor, the first time this has ever been used in a watch, which smoothly propels the continuously sweeping second hand. The other is a conventional step motor that drives the hour and minute hand, and the two are synchronized by integrated circuitry to keep them within plus or minus 5 seconds per month. It's a kind of hybrid between the automatic, kinetic quartz watches and something entirely new, that's still going after that continuous, sweeping second-hand motion which captured the eye of those original Accutron admirers. It was priced in the mid-$3,000 range and are positioned as high-end, innovative, conversation-starting timepieces with this rich history in revolutionizing wristwatches. And even before making this, I didn't realize just how important Bulova was. It was the largest watch manufacturer in the world for a time. It has that rich history in aerospace and even the moon landing, being a bold innovator unlike anyone else in their time, and paving the way for the current landscape of watches. 60 years after its introduction, the Bulova Accutron is remembered as an icon of American watchmaking ingenuity, and a milestone that fundamentally bridged the old and new. So even if the hum of an Accutron might not be on as many wrists, its impact continues to resonate, and hopefully will help to rekindle and capture the collective enthusiasm that defined the space age. Thanks for watching, please hit that like button, it really does help me out, and I'll see you in the next one.